All right, today we are going to talk about rational numbers, and I'm going to give everybody some really important instructions before you go any farther. It's super important that you are very comfortable adding and subtracting integers before you move into this lesson, or you're going to be really confused and you're going to be really frustrated. So I really encourage you to go back, continue to practice adding and subtracting those integer numbers before you start working on this lesson. That's super, super important. Now, let's talk about what rational numbers are. Here's a diagram that describes what we would call real numbers. And real numbers, we can start on the left-hand side in the green circle. Those are what we call natural numbers. That's what you first learn when you first start learning math. Or sometimes they're called counting numbers. 1, 2, 3, 4, 5, 6, 7, and we could go as far as we could count in that example. Whole numbers include all of our include all of our natural numbers, and they also include the number 0. Integers, which we've worked with this year, also include all of our whole numbers, so that means all of those 1, 2, 3, 4, and 0. But integers, as we know, also include negative numbers. Well, rational numbers is some work with some other things that we've actually done work with. We just haven't called them rational numbers before. You're going to notice fractions and decimals. Any fraction that either repeats or what we call terminate or ends is a rational number, and that's going to be true for decimals as well. Any decimal that has a repeating pattern or that eventually ends will be a rational number. Now, this year, we're not going to talk about irrational numbers. You can see them over on the right-hand side, and they're a special group of numbers all themselves. We have already talked about pi, and we know actually what makes irrational numbers irrational, and that's based on pi itself. Irrational numbers are numbers that don't have repeating patterns, and we know already with our work from Pi Day that pi is a decimal digit that repeats forever and ever and ever and ever and never repeats a pattern in that decimal number. And that's an example of an irrational number. But again, we're not talking about those today. We're going to talk about rational numbers. So let's look at some rational number equations. 1 plus 7, well, that involves rational numbers because rational numbers include all numbers that are whole numbers, counting numbers, and integers. 1/2 plus 3/4, well, those are rational numbers. And 0.25 plus 0.13, those are also rational numbers. So in this case, we're seeing equations that hopefully everybody can solve. We should know that 1 plus 7 is equal to 8. 1/2 plus 3/4, well, I may need to do a little bit of work to convert to common denominators, but that should simplify down to 1 and 1/4. And 0.25 minus 0.13, well, we can just line up our decimals and do some subtraction. None of this is new. You should already know how to do all of those things. So when we're talking about what we're doing with rational numbers, in this case, we really want to go back and focus on some of the things that we might not have included in this example, like negatives. In this case, I have negative 1/2 plus 2/3. Well, that becomes a little bit trickier. But if you're comfortable with our rules for adding and subtracting integers, you're going to do just fine with this. The only difference is that we also have to include our rules for adding fractions. So let's think about that. I probably want common denominators. I'm going to convert this to 3/6 plus 4/6 and make sure that I still got my negative sign on the number that's equal to 1/2. Well, according to my adding integer rules, same signs I add and keep, and different signs I subtract. Well, I see a negative sign and a positive 4/6, so that means I'm going to do some subtraction here. So let's rewrite this problem as 4/6 minus 3/6, and that's simply equal to 1/6, nice and simple. And then remember, we need to keep the sign of the bigger number. In this case, I'm going to look back and see that my bigger number was positive, so positive 1/6 is my answer. So all of our rules for adding fractions stay the same, and all of our rules for adding integers stay the same. Let's take a look at another example. Here I have 0.46 minus negative 2.26. Well, in our last video, we described and said it's a whole lot easier to add things than it is to subtract. So we know that subtracting a negative, well, we can really just add the opposite. So let's rewrite this equation as 0.46 plus the opposite of negative 2.26, which is just 2.26. And guess what? We've got a really simple math equation that you've been working on your whole lives. And we can solve that really quickly and see that our answer is equal to 2.72. Let's look at another example. 7.26 plus a negative 3.4. Well, following my adding integer rules, I would notice that I have different signs, so I'm just going to turn this into a subtraction problem. And once I've turned it into a subtraction problem, it's the same type of math that we've been working on all along. This process is not difficult if you've mastered how to add and subtract with integers. Again, if you have not done that, go back to the last video and some of the practice problems that are associated with it and really become a master at that before you move on to this one. Good luck. Let me know if I can help you.